In this video, I'm going to investigate arc length. All the formulae you need can be remembered from this diagram. Here we have an arc, PQ in red, and a straight line joining P and Q. As Q gets closer and closer to P, so the arc PQ becomes indistinguishable from the straight line PQ. And as we get smaller and smaller, we can appeal to Pythagoras, and we will get that delta x squared plus delta y squared is approximately equal to delta s squared. And if we now divide both sides by delta x squared, we will get delta s divided by delta x squared is approximately equal to 1 plus delta y by delta x squared. Now we let delta x get smaller and smaller and smaller. Delta s by delta x becomes ds by dx. Our approximate equality becomes an equality. 1 plus dy by dx squared. Take the square root, and we get that ds by dx is equal to the square root of 1 plus dy by dx squared. Integrate, that should have been the dx, integrate, and we get that s is equal to the integral of root 1 plus dy by dx squared dx. We could have done exactly the same thing, dividing through by delta y, and you'd have got ds by dy, you'd have got dx by dy squared, and you'd have got 1, and we could have had in exactly the same way, we have s is equal to the square root of root 1 plus dx by dy squared dy. When we have parameters, we need to think just slightly differently. We still start from delta s squared is approximately equal to delta x squared plus delta y squared. This time we divide through by the parameter delta t squared. Delta s over delta t squared is approximately equal to delta x over delta t squared plus delta y over delta t squared. Let delta t get smaller and smaller and smaller, and this becomes ds by dt squared becomes equals dx by dt squared plus dy by dt squared. Take the square root, we get ds by dt. We can write dx by dt as x dot squared plus y dot squared, and we're taking the square root. This gives us that s is equal to the integral of root x dot squared plus y dot squared dt. So we've got formula when we're using parameters, and we've got two formulae when we're using Cartesian equations. These are summarized here. Let's look at an example. Here I've got the curve y equals 2/3 x to the power of 3 over 2, and I'm asking to find the length of this curve between x equals 3 and x equals 8. The length of the bit which is solid, the rest of the curve is just shown for completeness as a dotted line. Well, here we're given a Cartesian equation in terms of y, so we're looking for the formula integral root 1 plus dy by dx squared dx. Y is equal to 2/3 x to the 3 over 2, and therefore dy by dx is equal to 2/3 times 3 over 2 times x to the half is just equal to x to the half. So now we get that s is equal to the integral as x goes from 3 to 8, root 1 plus dy by dx squared, x to the half squared is x dx. That's nice and easy to integrate. 1 plus x to the half must have come from 1 plus x to the 3 over 2. And I need 2/3 to make it work between 3 and 8. Putting the 8 in, I get 2 over 3. 1 plus 8 is 9. 9 to the 3 over 2, which is going to be 27, minus 2/3 of 1 plus 3 is 4 to the 3 over 2. And if you work that out, you get that s is equal to 12 and 2/3. Let's now look at another example. Here we've got the curve, it's a cycloid. It's what happens to the point on the edge of a circle as the circle rolls along. The equation is x equals a t minus sine t, and y equals a 1 minus cos t. Here we're given our equation in parametric terms, so we need to use s equals the integral of the square root of x dot squared plus y dot squared. X equals a t minus sine t, so dx by dt, or x dot, is going to be equal to a 1 minus cos t, and y is equal to a 1 minus cos t, and so y dot, or dy by dt, is going to be a sine t. We want x dot squared plus y dot squared, so let's look at that. X dot squared plus y dot squared. I'm going to have an a squared in everything. 1 minus cos t squared is 1 minus 2 cos t plus cos squared t. Y dot squared is going to be add a squared, which is outside the bracket, sine squared t, which is a squared 2a squared 1 minus cos t. Cos squared plus sine squared is 1, plus 1 makes 2, which I've taken out, leaving with 1 minus cos t. Remember, this is going to be under the square root sign. And it would be very nice if the 1 minus cos t was a nice square root. Well, you should be familiar by now with 3 ways of simplifying cos t with double angle formulae. And the one that we want is 1 minus 2 sine squared t over 2. Double angle formula. 1 minus 1 disappears. Minus minus is plus. 2 times 2 is 4. A squared sine squared t over 2. So that is x dot squared plus y dot squared. My arc length, therefore, is going to be the integral. One arc goes from t equals 0 to 2 pi, looking at the diagram. The square root of x dot squared plus y dot squared is 2a sine t over 2 dt. If I integrate that, I get, it comes from cos t over 2. Differentiating cos, I get minus a half. I'll need minus 4a from 0 to 2 pi. Putting in the 2 pi gives me 2 pi over 2 is pi. Cos pi is minus 1. That gives me plus 4a. Putting the 0 in, I've got minus because it's the bottom limit. I've got minus because it's minus 4a, giving me plus 4a. So the total length of the arc is 8a.